Hi everyone, Miss Pellegrino here. In this video, we're going to be starting on a new math chapter, Chapter 4, working on multiplying decimals. Today's lesson is multiplying decimals by powers of 10. This lesson is on page 130 in your math books if you'd like to follow along. Before we get started on this lesson, I want to do a little bit of review. For this part, I want you to pause the video and try these problems on your whiteboards or on a piece of paper. Use your knowledge of powers of 10 from our past math work. Go ahead and pause the video and give this a shot. All right, do you have your answers? If not, pause the video and let's go over them. Our first problem asked us 363 times 10 to the first power. Now hopefully we remember that when dealing with exponents like this, the 10 tells us what number we're multiplying, so in this case it's a 10, and the 1 tells us how many of that number we need. We only have a 1 here, so we only need 110. So this problem is actually asking us 363 times 10. We know that 363 times 1 gives us 363. There's 1 0, so our answer should have 1 0. We can use our zeros trick on all of these problems. Here we have 10 to the second power. That 2 tells us that we're going to have two 10s or two zeros on our answer. So what we're actually solving is 363 times 100, two zeros because of the 2 in our exponent, which gives us 363 plus 2 zeros. Our last problem, 363 times 10 to the third power, we know again that 10 to the third power means we're writing 10 three times, or just 1,000. So the problem we're actually trying to solve here is 363 times 1,000. We can use our zeros trick here, just like we've been doing. 363 times 1 is 363. There are 1, 2, 3 zeros on our factors, so we need 1, 2, 3 zeros on our product. So we can use our knowledge of zeros to help us multiply powers of 10. Let's take a closer look at that though. When we multiply by powers of 10 and we add zeros onto our answer, what are we actually doing? Well, when we multiply a problem like 363 times 10 to the first power, what we are doing is we're starting with 363 and we're adding a 0 to it to get this answer here. When I add that 0, what's actually happening is every digit got moved over one place in my chart to make room for that 0 in the ones. My 3 got moved up one place, my 6 got moved up one place, and my other 3 got moved up one place. When I multiply 363 times 10 to the second power, we said that that was 363 with two zeros. So here, if I put this number in my place value chart, I need two zeros and then my 363. Each digit has been moved up two places. The 3 went from my ones to 1, two places. The 6 in my tens place went up 1, two places. And the 3 in my hundreds place went up 1, two places to make room for the two zeros. Similarly, when we look at that 363 times 10 to the third power, we know that that's 363 with three zeros. When we put this number in our place value chart, we can see that every digit has now moved up three places in the place value chart to make room for the 1, 2, 3 zeros. The 3 that's now in my thousands place moved up 1, 2, 3 places. The 6 in my tens place moved up 1, 2, 3 places. And the 3 in my hundreds place moved up 1, 2, 3 places. So when we add zeros to the end of our answers when multiplying by tens, what we're really doing is moving everything up one place in the place value chart. To summarize, when you multiply by a power of 10, you are moving up on the place value chart. So what does all this have to do with decimals? Well, let's take a look at a decimal example now. Let's say I'm looking at the decimal 3 and 63 hundredths, and I want to multiply it by 1. Well, we know that any number times 1 is itself, so this is going to stay 3 and 63 hundredths. And I'm going to go ahead and write that on this place value chart for reference. When I start multiplying this by powers of 10, however, things are going to get a little bit different. Here I have 363 times 10 to the first power, which I've reminded us is the same as 10. If we tried to just add zeros to the end of our answer, we would end up with 3 and 63 hundredths with a 0 on the end. But we've learned with our decimals that zeros at the end of a decimal don't actually mean anything. The value didn't change. So this is not the correct answer. We need to move everything up one place on the place value chart, just like we did before. So instead of adding zeros, let's go ahead and use the trick we just learned. Let's move each place up 1 on the place value chart. And we're moving up 1 because there's a 1 as my exponent. So let's take this 3 in the hundredths place and move it up 1 place, put it in the tenths place. This 6 in my tenths place moves up 1 and goes into the ones place. And the 3 in my ones place moves up 1 into the tens place. So 3 and 63 hundredths times 10 to the first power, or just 10, gives us 36 and 3 tenths. Let's try another one like that, shall we? Let's take a look at the problem 3 and 63 hundredths times 10 to the second power, which is the same as multiplying it by 100. Now we know that because these are decimals, we can't just add 2 zeros to the end of 3 and 63 hundredths. That wouldn't actually change the value of the decimal. Instead, I need to look at this exponent, which is 2, and say, okay, everything needs to move up 2 places on the place value chart. So I'm starting with 3 and 63 hundredths, and I need to move each digit up 2 places. So this 3 from my hundredths place is going to move up 2 places into the ones place. This 6 in my tens place needs to move up 2 places into my tens place. This 3 in my ones place needs to move up 2 places and into the hundreds. So instead of 3 and 63 hundredths, I end up with just 363. Let's do one more like this, and I'm going to go ahead and erase the screen so that we can see a little better. For this last problem, let's try it with 3 and 63 hundredths times 10 to the third power. What do you think the answer would be? Can you use this pattern that we've been doing to figure it out? Remember, we're starting with 3 and 63 hundredths, and our exponent is a 3. So how many places do we need to move each digit up on the place value chart? If you said 3, you've got it. Each place needs to move up 3 places because we have a 3 in our exponent. So let's move everything. This 3 in the hundredths place is going to move up 2, 3 places. This 6 in the tenths place needs to move up 2, 3 places. And this 3 in the ones place, what place will it end up in? It'll move up 2, 3 places into the thousands place. So we end up with 3,600ths, 3 tens, and because there's nothing in my ones place, I need to put a 0 to hold the place. So we end up with 3,630. When we look at all of these together, we might be able to find a pattern with what we just did. Obviously, the zeros trick doesn't quite work the same with decimals as it does with whole numbers, but you may notice another pattern here. Do you see a pattern with our answers as we multiply by powers of 10? Pause the video and look for one. Do you see anything? You may have noticed that with each answer, the decimal point looks like it's moving. From here, it looks like the decimal point just moved one place to the right, going from 3.63, and the decimal point just moved one place to give us this. You might have said, oh, well, over here then, the decimal points moved 2 places to give us 363. Down here, the decimal points moved 3 places. So we can use another shortcut here. Instead of adding zeros, we can just move our decimal point. The exponent tells us how many places to move our decimal. To summarize that, when you multiply a decimal by a power of 10, move the decimal to the right for each power. So if your exponent is 1, you'll move your decimal point 1 place to the right. If your exponent is 2, you'll move your decimal place 2 places to the right. And if your exponent is 3, you'll move your decimal point 3 places to the right. When we do this, all we're doing is moving everything up on the place value chart. If using a place value chart makes these problems a little bit easier for you, go ahead and pull one out. Let's try a couple more examples together, and then you guys will have some on your own. So let's try this problem, 1 and 275 hundredths times 10 to the second power. Can you figure out what our answer would be? You can either use a place value chart or move your decimal point. Go ahead and give it a shot. Let's use a place value approach for this problem. I know that my exponent is a 2, so everything needs to move up 2 places on the place value chart. This 5 is in my thousandths place, so it needs to move to my tenths place. That's 2 places. That 7 is in my tenths place, so it needs to move 2 places into the ones. This 2 is in my tenths place, so it needs to move 2 places into my tens place. And this 1 is in my ones place, so it needs to move 2 places into my hundredths place. So I end up with 127 and 5 tenths. Let's try one more problem. This time, let's try the decimal trick. This problem is the same, except we're multiplying by 10 to the third power. So everything needs to move up not 2 places, but 3 places. I can move those up using the same method I did up here, moving everything up in the decimal place value chart, or I can just move my decimal point. My exponent is a 3, so let's move that decimal point 3 places to the right. So here's 1, 2, 3. The decimal point will go right after the 5. So I'd end up with 1,275 and no tenths. And I'm just putting this 0 here to show that there are no tenths. Let's have a couple more, and this time you try them. Go ahead and try these problems on your own. They are in your math book on page 131, numbers 2, 3, and 4, or you can just try them on a whiteboard or piece of scratch paper. Pause the video until you're done. Are you finished? Let's see if you got these problems correct. This first problem asked us 9 thousandths times 10. Well, this 10 means that we're moving everything up 1 place in the place value chart because we have 1 0. So that 9 needs to move from my thousands place 1 place up. So I can move that 9 1 place up, and it ends up in my hundredths. So I end up with 9 hundredths. Down here, I have 10 to the second power times 62 thousandths. This 2 tells us that we're going to move 2 places on the place value chart. So I can use a place value chart to move each one of these digits up 2 places, or I can use the decimal trick that we learned. 2 in the exponent means I need to move my decimal 2 places to the right. So it's going to move from here 1 place, 2 places. It'll be right between the 6 and the 2. So I end up with 6 and 2/10. And last one, we have 3 and 1/10 times 10 to the third power. This 3 tells us that we're moving 3 places on the decimal place value chart, or we can just move our decimal point 3 places to the right. Let's try that. I'm going to move my decimal point 1 place, and I don't have any more digits. Let's add a couple zeros so that we have more places to keep moving. So there's 1, 2, 3 places. So I end up with 3, 1, 0, 0, and then I would have my decimal point. I don't have anything else, so I can just add a 0 to kind of hold the place. I end up with 3,100.0. Your work for today is going to have more problems like these. Good luck, everyone, and stop in and ask if you have any questions. See you around.